everyone, and welcome to lesson 18.2. This lesson is going to start on page 241. Today we're going to talk all about graphing the transformations of those reciprocal trig functions and tangent that we talked about in the last lesson. So when we talk about the parent function of these functions, all right, we talked about how cosecant is dependent upon our sine of x graph, right? So if we think about graphing sine of x, we know that the graph will repeat itself by the time it gets to 2 pi. And despite my kind of off graph here, we know that normally sine starts at 0 and then it goes up, down, back to the midline, down, back to the midline. And we talked about then with cosecant, anywhere we touch that midline gets a vertical asymptote. Anywhere then there is a max or a min, you get a parabola, okay? Same kind of idea then for our secant graph deals with cosine of x, intervals 2 pi, and we kind of have to graph our secant graph based on our cosine graph, right? And again, both of these are going up by pi over 2 each time. And with cosine, we normally start at our positive amplitude, back to the midline, down, back to the midline, back up, vertical asymptotes at the midline, and parabolas at our maxes and our mins, okay? Now, from here, our tangent graphs then, we know are a little bit different because tangent of 0 is 0, but tangent's going to be undefined at 1/2 and negative 1/2, and then at pi it's back to 0, and then by 3 pi over 2 we're undefined again. So anywhere we're kind of at these values, 0, pi, not 0 and pi, at pi over 2 and negative pi over 2, we are undefined, 3 pi over 2. But actually here, we are going to have tangent, because like pi over 4 in between there is 1, negative pi over 4 is negative 1. So this is kind of our parent function of tangent. And again, they're special because it repeats more often. It repeats every pi units. Same thing with cotangent. It repeats every pi units, but it's a little bit different because by the time it repeats itself at pi, when we try to take cotangent of 0, that's where it's undefined. And then it's undefined again at pi. It's 0 at pi over 2. Now, cotangent of pi over 4 in between here is still 1, and 3 pi over 4 is negative 1. So it's going to kind of have like a reflective factor to it, if you will. So there would be our graph of cotangent. Now, we can start transforming then based off of these parent functions, because again, if we know that cosecant of x, again, deals with sine of x, and normally our parent function here would look like so, where we are up, down, and then back to the beginning here. Here's our parent function of secant. Well, if we are going to expand this to be at negative 2, we know we're going to have a reflection down, and this graph is going to be expanded so that the amplitude isn't at 1, it's at 2. So this is going to be reflected the other direction, although these vertical asymptotes would stay at the same spot. Another way of looking at this is thinking about, okay, negative 2 sine of x. If we were to graph that, negative 2 sine of x would start here, go down to back to midline, up to back to the midline, which again is consistent with that reflected value we just looked at. Cotangent then is not changing much in this particular graph other than we are moving it to the right, pi over 4. So normally our cotangent graphs look like this, right, where we have this shape to it, right? But this time we again need to move this to the right, pi over 4. So halfway between each of these is kind of pi over 4 units, right? Half of pi over 2. So what we're doing is we're shifting this to the right now. And we also, that means, need to shift our vertical asymptotes to the right, pi over 2. Okay, so there would be our new function here with everything shifted just a little bit to the right, pi over 4 units, okay? And then finally, tangent plus 2. Well, tangent normally is just here, follows along these vertical asymptotes here. But if we're shifting it up 2, it's going to now just be up 2 units, okay? The vertical asymptotes aren't changing at all, just shifting everything up 2 units, okay? So there's our tangent graph. Now, our parameters are not really changing compared to sine and cosine is in here. All right, a value is still, the absolute value of this is still talking about kind of that vertical stretch or shrink. And the negative out front of that is going to affect, if there's a negative out front, if there is a reflection or not over the x-axis. Now, one thing to be careful of, though, A is for the amplitude in sine and cosine only. Okay, so while it's affecting, again, this stretch or the shrink in secant and cosecant, officially an amplitude is none in all of our reciprocal functions and tangent, right? So secant, cosecant, tangent, and cotangent officially all have an amplitude of none, because if we think about what an amplitude is, it's kind of that max to the min. Well, okay, in a secant and a cosecant graph, there is no max and no min because those parabolas go up and down forever and ever. And then same thing with tangent and cotangent. They have that shape to them. They're going on forever and ever. So that's why officially your amplitude is none in secant, cosecant, tangent, and cotangent. It just kind of affects the overall shape of your graph, right? Kind of like the stretch factor, like we talked about up here, is still relevant, okay? Now, if we have plus C, again, that is a shift to your left. Minus C is a shift horizontally to the right, and plus parameter D means a shift up, a vertical shift up, and then minus D is a vertical shift down, okay? So those aren't changing at all. Now, we left off parameter B because you do have to be careful with parameter B now. For sine, cosine, secant, and cosecant, your period is 2 pi over B, but tangent and cotangent we've talked about, repeat more often, your period is just pi over B. So what we have to do here is when we look at our graphs, okay, if we're looking at an amplitude, again, for sine and cosine, it's still relevant. And for our period, we would still just be taking 2 pi over B. So pi over 2. Same thing with our sine graph. Amplitude still is going to be a thing. It's 2, period, 2 pi over B, which is 4 pi. So our period would just be 1/2, okay? So I'm not going to graph those just to save us a little bit of time. Tangent, though, okay, even though we have this parameter out front, officially the amplitude is none. And the reason the amplitude is none is, again, this goes from infinity to negative infinity. There isn't really like officially anything happening amplitude-wise. The official thing, we will stretch it vertically by a factor of 3, although in our sketch of our graphs, you don't see it as much, okay? Now, the two other things that are important, though, to note about this is that our period is pi over 2. Okay, because pi over B this time, again, our period originally was pi, and then divided by B is 2, so pi over 2. And we're shifting this vertically down 1 unit, okay, which means our midline is now down 1. Now, normally, our graph of tangent is going to repeat itself by the time it gets to pi over 2, right? And then negative pi over 2 is kind of that other side factor, or you could say 3 pi over 2. But we're changing the period. We're cutting it in half here, right? We're cutting our period in half. So really, if we cut this in half, it would now be from negative pi over 4 to positive pi over 4. And now that means the period is 1 pi, or excuse me, 1/2 pi. And then otherwise, our picture is allowed to look kind of the exact same, just shifted down 1 unit, okay? Now from here, if we talk about a graph of cosecant of x, okay, This is in comparison to our sine graph. So if we think about this with respect to sine of x when we go to graph, again, officially though your amplitude for cosecant is none, even though obviously there's a 1 out front. Again, it's always none with cosecant. Our period this time is 2 pi over b. So in this case, 2. So as we go to graph this, we need to repeat by the time we get to 2. So each of these are going to go up by a half. We divide that by 4. And then this is where graphing the original value of sine is going to come in handy, because we know it starts at the midline, goes up 1, back down the midline, back here. Okay. Now the only difference between sine and cosecant is the midline values get vertical asymptotes, maxes and mins, get parabolas. Okay. Cotangent is again going to not have an amplitude, and what its period is only going to be pi divided by b. So pi divided by 1/4, which is really pi divided by 4 over 1, or 4 pi. Now we are going to have a phase shift this time, right, pi, that we're going to have to account for. Okay. So normally when we talk about our graphs of cotangent, we know they repeat by pi, right? And we usually have vertical asymptotes at 0 and pi. Well, this time we're just going to change things so that it's repeating by 4 pi. So each little interval here is pi, right? We're going up by. And that's going to help us because we need to shift this to the right pi unit. So instead of being a vertical asymptote at 0, we're going to have one at pi. And instead of by 4 pi, it's now going to have to move one over to where 5 pi is at. Now, otherwise, our cotangent graph isn't really changing shape at all other than moving to the right 1 unit. So it's going to still just kind of have this shape to it. And now we showed 1 period of our tangent graph. Last but not least, when we talk about secant, again, in the back of your brain, you should be thinking a little bit about cosine, right? Amplitude, again, is officially for secant none, although the 4 is going to come in handy when we have to stretch our graph. The period is 2 pi over b, so 2 pi over 3, which is kind of an ugly period. And we have a vertical shift up 1 unit, okay? So, a couple things. Mark that we're moving up 1 unit. And then this time, when we are going to repeat, we need to repeat by 2 pi over 3. Now, to set your scale, what you're going up by each time, remember 2 pi over 3 divided by 4 is really the same thing as saying 2 pi over 3 times 4 over 1, or 1 over 4, because that's the reciprocal. And so 2 pi over 12 is really a scale factor of pi over 6. So kind of a gross value. And then 2 pi over 6 is actually pi over 3. 3 pi over 6 is pi over 2. And 4 pi over 6 reduces to be the 2 pi over 3. Okay. Now, last but not least, we shifted up 1. And again, we want to think about our pal cosine, right? Cosine normally starts at our positive amplitude. And so that's where this 4 is going to come into play. So we have 4, back down to our midline, down 4, back up to our midline, and then, oops, this needs to go down one more. 1, 2, 3, there we go. And then back up to our midline, or excuse me, up to the amplitude. Anywhere you touched the midline gets a vertical asymptote, maxes and mins, get parabolas, okay? So we have a lot of information going on here with these, but again, it goes back to being able to graph those parent functions. So we will work more with this in class, and congrats on getting to the end of activity 18.